What's going on, everyone? In today's video, we're going to take a quick look at two different ways to apply the Pythagorean Theorem, as well as a quick review in case you forgot about it. But don't worry, it's not too bad. So as long as you follow these steps, you'll get these types of problems right every single time. Let's go ahead and jump right in. So just to review, whenever you have a right triangle, these two sides are going to be called the legs. They surround the 90-degree angle, and then whatever side is the opposite of the 90-degree angle is called the hypotenuse. Okay, it's called the hypotenuse. It is also the longest side of the triangle always. That's important to remember in case you get a word problem where it doesn't explicitly tell you which length is which, but the longest one is always going to be opposite of the 90-degree angle. And if you remember, perhaps from previous classes or maybe in your curriculum, typically this will be called A, this will be called B, this will be called C. Why do I mention that? Because A squared plus B squared equals C squared, meaning that the value of this length here, squared, plus the value of this length here, squared, is equal to the value of this length squared, as long as you add these two together. So hopefully that's a little bit of a refresher. And let's go ahead and take a look at our first word problem. All right, so what we want to do on this problem is calculate the length of AB in this right angle triangle, and we're given that CB is going to be 15 and AC is 7. Go ahead and label the diagram accordingly. We want to know what this is right here from A to B, and we know that 15 is going to be the hypotenuse because we're given that CB. So again, as previously mentioned, we know that A squared plus B squared equals C squared, meaning that the one leg squared plus the other leg squared equals the hypotenuse squared. So if I know that one of my legs is 7, I can go ahead and square that. And I know that the one I'm looking for is this length AB, and then I know that my hypotenuse is 15. So as long as I represent that correctly, now all it takes is a little bit of basic algebra to solve for our missing value AB. So what does that mean? Well, it means that AB squared is going to be equal to 15 squared minus 7 squared. What exactly is that going to be equal to? AB squared would then be equal to 176, and then we're going to have to take the root of each side. So technically the root of 176 would suffice. It depends if your teacher wants you to simplify this or give it as an approximation in terms of a decimal. So if you wanted to express this in simplified radical form, you'd go ahead and do 4 root 11. If you want it to be exact, in fact I should use the squiggly equals because I'm approximating, you would have 13.3 centimeters. So as long as you are representing this correctly, use the right algebra steps, you'll go ahead and get this right every time. Just make sure that you're paying attention to whether or not your teacher or the problem wants an approximate decimal answer or a simplified radical form or what have you. Now what we want to do is see if we can prove if 3 sides make a right triangle. We're not exactly given a diagram here, but that doesn't change our thought process really at all, because we want to determine whether 6, 8, or 9 is a right angle triangle. So maybe it'll help if I actually drew it, since a diagram is not given to us. Go ahead, Shane, and cut to about there. All right, so I know that this would be 6, this would be 8, and again, opposite of the 90-degree angle is my largest side, my longest side, which in this case is 9. So the question is now, does one of my sides, let's say 6 squared, plus the square of my other side, 8, does that equal to the hypotenuse squared, 9? Now, what you can do here is, well, solve the left side, see if it equals to what you find on the right side. So if I had 36 and then 64, does that equal 81? Well, this actually equals 100. And does 100 equal 81? No, that is a false statement. So what does that mean? It means that 6, 8, and 9 do not form a right triangle. Those 3 lengths, when used together as lengths of a triangle, it will not form a right triangle, because we can use the Pythagorean theorem to prove if 3 sides do or do not make a right angle triangle. In this case, they do not. And that's how you do that. All right, let's take a look at one more example problem before we wrap this video up. So let's say someone has a vegetable garden, and it is a triangle. It's a triangular vegetable garden. And we want to prove that this is indeed a right angle triangle. So we know that the measurements are 17, 144, and 145. Is this indeed a right triangle? Well, you can kind of probably tell that if this is 17 and this is 144, again, this is obviously not to scale, but it would be something like this. It'd be a very kind of, compacted shape like so. So again, 145 is our longest distance, therefore it is going to be our hypotenuse. It's going to be opposite of the 90-degree angle. So just like our last problem, we're basically asking, hey, does the square of 17, when you add it to the square of 144, does that equal the square of 145? And now you might want to use your calculator here. You can if you'd like. So basically what you're saying is that 17 squared is 289. Then you're saying that 144 squared is 20,736. Does that equal 145 squared? And you know what? I'm actually going to do this in a slightly different way, but it's not that big of a deal. And if you add these two numbers together, you'll find that it is 21,025. So the question is, does that equal 145 squared? Another way of doing that, and again, I'm just doing this just kind of for the sake of variety, is if I actually took the root of each side, what would I get? And it turns out that I would actually get 145 equals 145. So in this case, yes, the lengths of 17 and 144 and 145 do indeed make a right triangle. So we proved that this vegetable garden is indeed a right triangle. So those are two very basic applications of the Pythagorean theorem. One of them is to prove, hey, what is the missing side, given that it is a right triangle? And the other one is to say, hey, we have three sides. Is this indeed a right triangle or not? So I hope this helps a little bit with our kind of introduction into geometry, and I'll see you all in the next video.